what it says is from 0 to 1, and then cosine x squared dx. Okay, so they give us that n equals 6, I believe. Yeah, they want us to find S6. So this is what they're asking us to find. So this is the Simpsons rule 1. So our A to B, A equals 0, B equals 1. Okay, so we have that, well, okay, there's also, you know how when I was doing like the little interval thing, when we would break from A to B up into however many little parts? So this is going to be 6, so that's kind of 1, 2, 3, 4, 5, 6. So this is going to look like that somehow. And cosine, that is not the graph of cosine, I can tell you that. But anyways, we're not going to go into the graphing part. But here's our formula. So we have Sn equals 1 over 3 delta x. And then we have, remember this is the most complicated one, I guess you can think of it, of the 3 types that there are. So this is actually what we're going to have, and we're going to go up to y6, right? So we still have the numbers going here, and then y4 plus 4, y5 plus y6. Okay, so this is, so this is S6. And then the way to figure out delta x, that's the length of one little interval. So basically what you do for delta x, this is like a mini formula. So you just do b minus a divided by however many intervals you're doing. So in this case, our delta x, so delta x is going to equal b minus a, so that's 1 minus 0 over 6. So delta x equals 1 over 6. Okay, so now we know delta x, and then here comes like the laborious part where you have to figure out every single y that we have here. Okay, alright, so I'll show you how to do that on the next slide. We're going to need some room. Okay, so y naught equals f evaluated at x naught. Okay, and as we know, x naught is our first value, so that's our a, which is 0. So we just want to know what f of 0 is. So that would be cosine 0 squared, which equals 1. So yay, that's the first one. And now we have to do all the others. So then we have f of x1 equals f of, and x1 is now going to be 1 over 6, right? That's our next point on our interval. That's like our next mini interval. So we have a here. So, well, a is 0, right? So a is 0. And then let's say 1 is over here. 3, 4, 5. Okay, so 1 is here. And then our little intervals, because they have to be even, 2 over 6, 3 over 6, 4 over 6, and 5 over 6. And the last one is just 6 over 6, which is 1. So these are all the points that we have to evaluate f of x at. So this is going to be, and I'm not going to write them all out, like the cosine part out, because that's just going to take up more time, and I don't want to waste your guys' time. So y2 turned out to be something like this, and mind you, I did this, I checked it twice. However, I would do this on your own. I would recommend that you guys plug in these numbers on your own just in case, because, yeah, sometimes my calculator does some funny things. So, just a heads up, if you get this wrong, please don't blame it on me. But the method is right, I can tell you that. So, yeah, just calculator problems over here on my end. But, okay, and then this is what I got for that. Oh, and also, additional note, the cosine, well, okay, so this f of x equals cosine x squared. The x squared part, this is being measured in radians, not degrees, because when I tried it with degrees, it didn't turn out so well. So I believe it's in radians. And, okay, alright, so now we have these values. So they're kind of scattered, I'm sorry. But, yeah, so we're just going to plug it into the SN formula. So what we get, I'll write on the next slide because it's going to be kind of long. So now we get that S6 equals 1 over 3, and our delta x was 1 over 6. So then we have like a 1 over 18 out here. And then we have our 1, and then we have to, don't forget the pattern, remember, so 4 times y1, which is 0.9996, plus 2 times y2, which is 0.994, plus 4 times y3, 0.969. Going down here a little bit, 2 times y4 is 0.903 plus 4 times 0.768. Oh, I'm not going to make the last one. I might. Okay, y6 is 0.54. Okay, that is going to be it. Yep, that's a 4 at the end. Okay, so this actually, when I plug it into my calculator, it turns out to be about 0.905. And again, this might or might not be exactly correct. You should check it on your own with your own calculator. Okay.
Go.